Hey everyone, I'm going to show how to get a signature for the item info, experience info, and other infos that are used in the game. This is a big amount of data that's usually loaded in from image files, such as this one here, G03, Gdata, D01, G image 2D, 005, 005, 001.img. So basically, in a function of the code, it has this big long tree where it loads in different game resources during initialization. It's massive. And this is the one where you might have seen alerts when you don't have the right parameters, or the font's corrupted, or when you've modified something and it doesn't load because of some sort of checksum. That's where they'd come up in here. So if we go down to following it where we want to go to items, it's going to be a while down. This one's level, do them later, this one's items. Right, so it pushes an address to the file name. It also pushes an address to the object to use. So in this case, I've already worked out the structure. It's just an integer for how many records, and then it has a pointer to the record data. Then it calls the item init function, which will load the item. This offset here is the one we actually care about, so we will query for that using a signature. This signature might not be big enough. So I've got a plugin to generate signatures under Edit Plugins called MakeSig. Its hotkey is Alt F9, and you just want to create a code style plugin. Text style for now. We'll test it in Cheat Engine. So there is our signature. And if we copy paste this into Cheat Engine, searching for an array of bytes, we should find it. But hopefully it will be the only thing there. Got to make sure you're searching array of bytes as hex ticked, and you have to be searching executable and read-write memory, I believe. So to make this faster, we can check only executable, paste it in there and search, and it will show us everywhere in the code that signature is found. So there's quite a few. 40260C. Is that going to be it? 402642. No. 402642. There it is there. Do we want to use this signature, or do we want to find something more exact? I think I'll go for something more exact. Press spacebar and switch into this view, which shows us every page. And I'll actually make it a bit bigger. And bloody windows on this size. Right. Let's close it. 402642. It's still found. It's the second one. Let's see. Level item something. Level item, whatever that is. NPC, maybe? Monster, NPC. So it's 1, 2, 3, 4, 5, 6, 6 things. 1, 2, 3, 4, 5, 6. There's 6 things using this pattern. So this pattern is going to get us all this code, every one of these addresses that we need. So that's nice. And the address we want is going to be the second question mark in the pattern. So let's put word wrap on. So that one there corresponds to, say, this one or this one. It's whatever the offset is for the file name. 68 is push. So B9 is going to be our move into ECX, and can tell somewhere. Can't remember where it shows. Oh well. B9, and it's going to be this one here. So we make that X's. And we should write down the list of things that we get. So we've got level, and then item, unknown, level, item, unknown, monster, NPC, I think. Yep. NPC quest. And that's it. 1, 2, 3, 4, 5, 6. So that unknown's going to be skilled. So no, it's a skilled database there. And that's our order of things we will find. I'll just cut the video and skip to actually coding this in. Before I forget, I'll just show you the item info structure we've got. So in IDEA Pro you can have local types, which is really handy. And the basically C structures, sorry, C++, I think, I'm not sure. And you can write them like that. And this one I've known for quite a while. It's the same as the one in 12SCO2. For when any info is loaded, there's 6 infos loaded, it has a D word for the record length and then a pointer to whatever structure for the info data. That data is compressed in some versions of the game, so it's actually dynamically allocated, and that's why we've got a pointer there. So I've got like the item infrastructure, which we've been working out forever basically. You got your ID, you name your item, and so on, you know, like anything importance in here. We've still got a lot to work out, I guess. And the reason why I'm doing these signatures is for translation of the game. We need to overwrite some of these values like name and descriptions, wherever they are, with the data from a CSV file, which we've been working on collaboratively in Google Docs. So with that structure found out, I know it's at this offset here for the actual object, and if I was to go to that by double clicking it, you can see there's an address ACC120. If I go to that address in Cheat Engine, because the game's actually running, I think that's it. Here's our record length, which 99999 or something like that. Yep. And then after, which is +4, is going to be our pointer to our structure of item infos. So yep. Derping for derp mode. For what? And want to view it in hex. So if I go to that address, we'll actually see the item data. And my game is currently in Korean, so this was a bunch of gobbledygook. I can't even see like the other items. And I've just found the one for silver because that's the first item, and I've changed it to say 1337. And all our code in our DIL is going to do is overwrite all of these text strings to be something we can read, something we know, something we can understand, and this could work in any language. I'm going to do English. Yeah, that's the structure. Why I need it. Why I need this SIG. For CSV parsing, I'm moving away from string toolkit, and that's called strtok, string tokenizer or something, to be using CSV parser. The reason for that is, unlike strtok, it actually handles empty strings. I ran into a problem where if you had two delimiters with nothing inside them, it would actually skip them, and it was having completely the wrong result here. As you can see in the description of Fortune Touch, it has a 1, and that's actually the next field over from the descriptions. With the signature scanning lib, we have a find all method, which we should be able to use to find all the occurrences of a pattern with an optional between start and end value. Start address. So let's give that a go. Doesn't have a net value, so that'll be interesting. So it's expecting an input param of a vector that'll store your addresses that it finds. What's your signature string, which we have over here. And results ampersand from. No, I don't know what this is called. Really remember. And give it string. I don't remember if I can have spaces or not. Now it'll automatically read out that address as a pointer. We have some other work to do on that to +4 to that address and read the pointer that's there if it's set, and if not, we want to wait until it is set because the game will load those resources. What else am I missing? Set, give it an offset +4 to skip the junk. And skip the record count, sorry, and from start. That's already going to be true. And start address is 0. So for the start address, if we want to be more specific, we can specify an address closer to where we are in our code, but memory scanning is really quick. I'm not going to bother. If we want to optimize later, we will. But just code it first and optimize later. You need to, because this is just hacky. It only runs once anyway, so yeah. Just skipping ahead, I have coded in using the signature and actually overwriting the strings in game. I'm using CSV parser with fix I've submitted a pull request for to fix a problem with that, and it seems to be working sweet. Really simple to use, so I've just done sig find all, given it the vector of unsigned long of where I want it to store all the addresses it finds of the signature, and there's the signature with the part I want actually as a pointer of x's, and I want to offset that by 4 for items, so that's what I'll put the offset in there as. And then I'm just doing normal memory protection things because we want to change the protection to read, write, execute, or just write or whatever, and then make our changes and change the protection back. Then I pretty much just iterate through all the different 1 through to 6 of the instances of the signature we've found, and for each of their address I know that in the order they appear in the code it goes level, item, skills, monsters, NPC, quests, and it's been like that since the game first came out basically. Well, after they added quests, there was a beta release. I think it didn't have quests or something else. So it's going to be in that order. So my CSV files are named levels.csv, items.csv, and so on. And I think I can show that here. Data translation, items CSV. So what this is going to do is it's going to read in this entire CSV, and it's going to read the ID, find the correct address, and write the name and descriptions over what is in game memory. And that is done further down here. We get if it's for items we're processing, we get the item ID, turn the ASCII string into an integer. For our output map, we're just going to contain the fields, and header front is going to be ID, it's the first column, the first row. And every time you use a string, for all the old string functions, you have to turn it back into a C string. Then I get the address, so that's going to be the value from our iterator, which will be the address found from the signature scan and find all. 352 is the size of the structure. Could probably actually use size of item info because I've already defined the structure. And item ID takeaway 1 is going to get us a 0 indexed value that we can use to find the position of our actual info for the item. We've got some log writing that writes out the log nice. I'll show that. It's real simple. Formatted strings, you have a percentage and then your format type. Here we're saying pad to the left with 4 zeros, and it's an unsigned int. This one, %s, is saying it's a string, or C string, and 08 capital X is saying output hexadecimal, capitalized with leading 0 paddings for 8 characters. So here we create a item info pointer called II, and we assign it the address, and we just cast it to an item info pointer so that it matches. The other way to do this, if you don't have a structure but know the offsets, would be something like just using it directly plus the offset and casting it to whatever data type you need. So for string in copy, you'd want a char pointer. The other important thing is to have the length of the field you want to copy. So here we're just using 28 and 25 for the descriptions, and that all works pretty decently. It will give us a log like this. No, wrong folder. You can just see all the items in there. It's got the item ID and the name and the address it was found at, so that can be handy for debugging later. It looks for the other translation files, but there are none, so it just skips loading them, and it'll probably be that way until we've coded in handling them. And if we go to game, we've actually got the values with English description, English names, and I am using the Korean data. As you can see, the NPC names are gobbledygooked. And same with the skills. I don't remember how to open the skill book. I think it's Y. No, it's not T, it's R. There we go. So yeah, that's that for signatures and finding all of them, I guess, and translating. We need to implement the other translations, but it should go pretty sweet. I will post links to the Google Translation pages below. As you can see, they're all on Google Docs. I've got them collaboratively shared. If you know how to translate Korean to English, please, and you want to help out, please contact me, and maybe I can give you access to it so you can change anything we've got wrong. If you want to fix up the grammar or spelling or whatever, just let us know the ones that are wrong, and we could probably fix them up for you. And we'll look at some sort of system to patch this in the client's launcher in the future. Cheers.